Okay, let's try this again. Unit 10, notes 3, take 2. So on example 1, as we've done in previous homework, I'm going to take the square root of both sides. X minus 5 is equal to plus or minus root 6. I add 5 to both sides. You get 5 plus or minus root 6. On B, I'll take the square root of both sides. This time I'm going to imaginary because there's a negative under the radical. So x plus 2 is equal to plus or minus I root 5. So x is equal to a negative 2 plus or minus I root 5. Completing the square. Let's see what happens if we complete the square with imaginary roots. I'm going to subtract 13 from both sides first. I'm going to take half of that, which is 3, and square it. And if I add 9 on the left, I got to add 9 on the right. That's a perfect square trinomial, of course. Square root both sides. Because I have a negative under the radical, I get imaginary, and square root of 4 is 2. Subtract 3 from both sides. B, remember, this has to have a coefficient of 1, so I have to divide everything by 2. I'll move that 5 halves over to the other side. I'll take half of 1, which is a half, and square it. So I'm actually adding a fourth to both sides. Square root them. Y plus 1/2 is equal to plus or minus 3/2 I. So negative 1/2 is equal to plus or minus 3/2 root I. All right, so let's use the quadratic formula, which is opposite of B plus or minus B squared minus 4AC over 2A. And we'll use the quadratic formula, and then we'll talk about what happens with the roots that we get. So negative 6 plus or minus 36 minus 4 times 1 times a negative 2 over 2. That's going to equal negative 6 plus or minus 44 over 2 is equal to negative 6 plus or minus 2 root 11 over 2. I could divide out a factor of 2. All right, I don't have a negative under the radical, so I have real answers, and I have 2 of them, and they're going to be different. One's going to be negative 3 plus 11, and the other is going to be negative 3 minus root 11. So 2 unequal real roots. And it was a real root because I didn't get a negative underneath the radical. For B, I have 48 plus or minus, no, I have 4 root 3. And the 48 goes on the inside. Minus 4 times 3 times 4 over 6, which is equal to 4 root 3 plus or minus 0 over 6. Should be 4 root 3 over 6. We need to simplify that fraction. So I have 2 root 3 over 3. Whenever we have a quadratic equation, we need two answers. In this case, it's the same answer, so we would say that we have a double root. On C, we'll have 6 plus or minus 36 minus 4 times 1 times 10 over 2. That's going to equal to 6 plus or minus a negative 4 over 2. Got a negative under the radical. I'm going to get an imaginary answer. So 2 plus or minus 6 plus or minus 2i over 2. Divide out of 2. 3 plus or minus I. So this time I still got two answers, 3 plus 3i and 3 minus I. So I have two imaginary roots. Three plus I, 3 minus I. So these are conjugates of each other because they have the same numbers but different signs. So we have two imaginary conjugate roots. All right, so the part of the quadratic formula that determined the nature of a root was the b squared minus 4ac. If that was positive, I got two unequal real roots. If that was 0, I got a double root. And if that was negative, I had a negative under the radical, then I had two conjugate imaginary roots. That b squared minus 4ac is known as the discriminant. You will need to know this, and this when we get around to having a quiz and a test for this unit. So you just got to have, maybe make some flashcards or Quizlets or something. So let's use a discriminant to find out what the roots are going to be. So we'll take a 49 minus 4 times 3 times 5. And that's going to give me 49 minus 60, negative 11. So I have a negative underneath the radical, essentially. So I'm going to have two conjugate imaginary roots. And that's because if I would actually use a quadratic formula, I'd end up with a negative underneath the square root, and that would give me imaginary roots, not real roots. B, 169 minus 4 times 2 times 15. 30 times 4 is 130. If I take that away, I got 39. So underneath the radical, I got a positive number, and so I'm going to have two real unequal roots. See, if I square this, I get 4 times 3, which is 12, minus 4 times 1 times a negative 1. That's going to be 16. So again, I got two real unequal roots. For D, I'm going to clear the fractions, multiply everything by 4, and get x squared minus 10x plus 25. So my discriminant would be 100 minus 4 times 1 times 25. 100 minus 100 is 0, which means we're going to have a double root. All right, those are the notes. If you have any questions, hit me up on Google Chat, and I will see you in